Hello and welcome to another video. I thought I might look at doing another operating system project. I've still got the old one, so just to give a demo of that, if we kind of run that, it should kind of do a thing and spin up a thing. Has like a few commands that you can run. It has some tests that you can run. There's run tests, I think. Might ask you for stuff. Yeah, it also asks for me to kind of put in the right characters. Ooh, did I not do that? I don't know who made this thing. But yeah, so I've still got that. But I thought I would kind of start on a new one. And I've kind of already got a few things. Is that like a better one? Yeah, that doesn't show the Git stuff. So this is kind of what I've got, and you can kind of see here that I've got some source code for an assembler of some description, and then some source code for just a BIOS. It doesn't do too much at the moment. You can see here that we've got some tests, lots of tests for the assembler, and not so much for the OS at the moment. What I thought I might do is kind of look through some things. So there's some stuff that's kind of hanging around, but we can probably get rid of that, and also that, and so we should just have the one thing, which is kind of my what I'm working towards being able to do. So this is very limited source code. I might pump this up like even more. So this is like even this is quite limited source code, but this was like enough assembly to be able to boot on a x86 system. All you need is these two magic bytes at a particular offset. So at the moment, my compiler does not compile this, so doesn't even do anything. But it does do a few other things. So what I could do is I've got this thing here, and we can maybe start at our test harness type thing, I guess you could say. It's just a shell script, and all the tests are in shell script. It's reasonably basic, but what the harness does is it kind of defines a few functions. So we've got fail, we've got test size, which suggests that the output binary is of a certain size. We can get a particular byte out of that binary, and we can test whether the byte is what we expect. We can test whether the boot log. So I guess what I could do is maybe in this one we can run the OS, and as you can see, it kind of outputs some stuff to the screen, and that's all it does. It does even less than the other one, but it's what I've got. But yeah, so this test bootlog contains will kind of run Kimu in a particular way, basically outputting the serial to a file and not having graphics, and then you can kind of test whether you have the right thing. And this test is quite silent, so it won't tell you what went wrong if something went wrong. The assembling ones are a bit better. But yeah, so we can also test whether we can assemble something, and this will kind of read in some expected input. No, yeah, so it will have a parameter of the input, so our $1 there, and then it will read in the expected input, and it will base64 it so it can store null bytes fine. Then it runs the assembler, checks whether it died, and kind of pretty prints errors, I guess. and if the output doesn't match, then we kind of show it maybe in a format that's a bit easier to read with XXD, and then you can kind of see which bytes do which. I've also got a test assembly error. This is basically testing whether the assembler outputs an error of a particular thing. And this takes a couple of parameters, and it will kind of test for where's my $1? The $1. Yeah, so $1 is just the input, and the $2 and onwards potentially. $2 in particular is looking for the file offset. So it'll say at this point in the file, this is what the error was. So this will kind of check that the error is right. I might just get rid of that while I'm here. And then it also, if you have more parameters, it will check whether that matches what the error message is, I guess. And it's quite crude. It basically does a grep with all your arguments like that. I have a little helper function of a way to make a literal byte that you can then pipe into something. You can't save it to a parameter if it's got a null byte in. You can if it doesn't, but if it has a null byte, then plain. This is the crux of the whole thing. Basically, we check that we're in the right directory. Go to it if not. Check what we want to test. If we don't say anything, potentially if we don't say anything, I should say this should be all. And otherwise we and the org basically just runs the same program again with assembly and OS as the arguments. Quite crude, does what it does. The OS, we see if we already have a build file. If we do, we kind of move it to a temporary file and move it back afterwards, just in case I've got something that I don't want to lose. Then we build it, which might override it. We also should have a RM build file probably there, and maybe pipe it to div null just in case there isn't actually something in there, because this I don't think removes it. Nah, but it might get rid of it. So we remove it, and then we build it, then we make sure that it actually makes a file. So this remove then test is kind of making sure that, so this is like you set up the test, and you do the test, then you assert the test type style. If you have arguments to this thing, it will then kind of test it. It will assume you're only allowed one argument, but if you have one argument and it is a file under the test/os directory, then it will run it. Otherwise, it will run all of them. And the assembler basically does the same thing, and I might do rm asm and to do null just in case. So like this would do it if it kind of already exists. Well, I guess like, yeah, if it already exists, then we're kind of getting rid of it. So we don't need to do that. Yeah, let me take that out. Past me has already thought of this. Otherwise the assembler does the same thing, but in a different directory. And I guess we don't have that. We have this. We'll go back to that, which should reset. Oh no, we've still got a change in this file. We changed it. Reasonable default, I think. And so in our assembly test, we have a few. Perhaps it might be easier to test slash assembler. Well, I'll show the OS ones. There's only a few. So we check that the file size is at least 512. You need one sector. And we check that the magic bytes are the right things. and give it an error if not. And like that error could probably go into there, and then the fail I can potentially get rid of because I'm running it in a subshell. I can put on set minus E, and then it will just exit as soon as you have any error, and you can trap on that error, and then basically do your fail or whatever. And the fail kind of outputs the test file that it failed at, and the line that it failed on. So like there might be multiple lines in one file. And it's kind of handy for my editor. And it was me pondering like another way to do it, and like then I'm like, do I want to write a parser for a test harness or just use like an existing one? And I went with an existing one because I thought having tests might be good. And we also kind of do some rudimentary integration tests, basically see that it actually spins up, can actually find the right disk, and it gets a message from the operating system. So that's that. The assembler has a few more tests. So the first one is I have a little flag here. Basically, by default, I'll just do like 50 random numbers, and basically, well, I suppose it's 100. I'll test it with a positive number between 0 and 255, and then I'll test it with a negative number between negative 128 and 127, if I have that right. And then that kind of does that. If I change that to false, then it will kind of do this one, which does the entire range to test everything. So I do that every once in a while. Here we have string, character support, and also escape codes for the thing. So basically, we pipe in what we expect the output to be, then we give the input, so the assembly source, and then this will kind of work out whether it is right or not. And you see I kind of rely on printf to basically do the same thing, but he doesn't have that, but that's all good. We've also got arithmetic, so you can kind of do basic assembly time arithmetic, which is useful for things like my source code that I wanted, which has like an arithmetic E thing in this times expression, which I'll get to quite soon. Also has support for string, so you can kind of have a quoted string, and perhaps I might have a like Z quoted string, which will chuck on a null byte. Or like a C prefix. I can do that because it's like my language. And then I also kind of test certain error conditions. So at the moment, all it kind of has is the DB, which is for data byte. So you can put a byte in at the place that you're assembling. And so this is kind of checking that you are doing the right thing. So we have some edge conditions for our out of boundsness. And we also kind of check I don't think we do much checking of hex and octal. Perhaps I should do a little test for that, which could be just in this kind of loop. It reprints it using bash as the octal or hex and does that. I suppose here I kind of do that in a sense, very rudimentary. I also support the byte, so you can specify each bit, which can be quite handy. So that's that. I think I have, yeah, I've got like almost 1,000 lines of C code, perhaps more if we look at the C header code as well, which perhaps I will get into. So I guess if we go to ASM, I have a few things. Perhaps I'll bump it down like that. So I've got a few little helpers. Basically, a little thing I can say here and print like a formatted string, and that way I can like search for here, both in output and in the source to find where the here thing is, like where a thing is printing, because sometimes you're like, where is that thing printing? I've also got a to-do, which will also abort. So basically, I haven't done this. It's unimplemented, whatevs. And I've also got an unreachable, which is for cases which should be the case, but not the case. So basically, I've my mental model in my head was not right, and something in the code is wrong. And ideally, it will be at the place where I need to fix it. Now, I've got this thing here, arguments list, which is a kind of unique thing. I've been playing around with these things called X macros. You can see some of that on my DT emulator show, but so arguments list is basically a series of macros. So these are just macro functions, and you just have to specify them all. So X, S, L, E, D, and C. So X is basically this is what the thing is. It's like a enumeration tag. S is like a short option, so it's a character. L is like a long option, so this would have like a single dash before it, and this will have a double dash before it, type thing. And E is like any extra arguments that you might have. So for help, there's none, but for output file, there is something. D, we have the description. So this is just the description of the thing. And C is the code. So this will kind of use this function here, which is defined somewhere. And it'll just print the usage and quit, which is what say that will do. And here, specify the output file path. It does a bit more. It kind of checks whether you have the extra thing, and it will kind of complain. I could maybe refactor that error handling out, but for now I've only got these two options, so it's probably fine. But I might add more. Who knows? So here we also have so we get the next argument, so next arg, that's just a macro that basically decrements argc, which is in the scope, and also it decrements argc, but it increments argv. I had that round the wrong way. So here it also says that this path is not allocated, because it could be allocated, and this is just a little tag to say whether it is or is not. Perhaps I could do that in a different way. So this is just a, yeah. So I guess what I might do is kind of walk through first work out what I changed, and yeah, nothing actually changed. So if we go back into that arguments thing, here is it's an arguments.h, but it actually has source code in as well. So it's what you call a single header library, or something like that. Words lost me at the moment. But basically, we do some checks. Do you have these things defined? Otherwise, no, you need to define it, and they'll kind of come as a compiler error, which is quite handy. Otherwise, we do some checks. This is just a normal header guard type thing. So if it's not defined, we define it and do all this stuff. And all this stuff is a bit of stuff. So we need a library header, so we get that. We first define all these things to just blank. So this is where the magic is. So these are all blank, but then here we now define X to be just whatever it is with a comma and a space. The space is optional, but what this is going to do is when this kind of expands out, it's as if I've written each of those things with a comma and a space. The space is optional. And then because I have a comma at the end, I need to have something else at the end. And it's kind of a good place to have a num arguments type thing, which will just be a token saying how many arguments we have in. And we could potentially use that in ways. Currently, not used that much. Well, I actually know it is used for printing out stuff. So here we have, so now we kind of define X to be blank and undefine S because you can't like redefine things. Then now redefine it to be, get that S, which is the short code. So here we get the, basically make an array of the short codes, and because we have to have something at the end, because of the comma, we jump something at the end, and cool, now we've just defined that. And like that saved quite a lot of code, like number of lines of code. You could put it all on one line as I have, but normally you would put it on multiple lines as it was kind of in here. You would have that on one line, that on one line. But you would have it in this place, and this place, and this place, and this place. So like this whole thing kind of makes it a lot easier to kind of make all these things. So we basically have an array for all of the options that we kind of passed in there quite easily. We have a few things that we need to do. So process is what we kind of call it the start. And this also takes an argument config type, which I believe I have in here. I define it as asm config, and that's basically everything. When we pass the arguments, we're going to pass in that config. And it's basically a user data type thing that we can kind of put stuff into, because those arguments need to know about it. So that's that, but I kind of skipped over this kind of bit. So this is kind of where the header part of this whole thing ends. So at the top we had this header guard, and then we end it. And then we have this thing, which I think is meant to have an undef arguments implementation afterwards, just in case. I don't think I kind of do that. Yeah. So what happens here is back in the main file, so asm.c, we have arguments implementation defined, and we do it before we include that. And the reason why is we might have another file that we want to include this to get access to these definitions. It's just something that you might want to have. But if you don't define this, then all of this code, which is pretty much to the end of the file, the only other one is this kind of first check, won't be there. So you only want it once because this is a definition of the function. And if you have multiple definitions at link time, it will fail to link. It's just what it is. And so how do we print usage? We have like a little print define, and the only reason for this weird print define is to do some error handling. So we check whether the return code of that print was successful and fail if not. And we also keep track of how many things we've written, because we're going to return that. It's what the fprintf, well, it's what the printf family kind of does. And I'm kind of making a printf type thing, I guess. But all it's really doing is it's printing to some type of stream. So you might have a log file, you might have a just standard error, or you might choose to have a standard out. Like if you do dash dash help, that usage you probably want on standard out, but if you do like a bad error, you probably want to understand the error, something like that. So what this does is it basically says usage, and it has the program that you pass in, and you'll pass in like argv, the first thing, and then it uses that num arguments that I said wasn't used. It's actually used quite a bit. If num arguments is more than 0, that means we've got some arguments to kind of print. And if we do, we kind of say, you've had some arguments there. And this kind of, it's hard-coded to my specific thing, but this one potentially should get like put into another define type thing that I have an extra parameter after all the arguments that I've listed. I could potentially do that now. You would do something like if arguments extra. Actually, no, this isn't what I want. I want something like this, and like do something like that, and then like if def that, and then end that, and then this we would probably just do arguments extra, and I think that we want that to come out to there, because we only want to print that line sometimes. So now I suppose I'm put in the arguments extra into my buff asm. If we go here, we can do define arguments extra, and we can just have a file name type thing. And perhaps we can put it up there just to say that we are expecting some extra stuff. So if we're printing the usage, this is basically that. And then again, if we have some arguments, then we're going to print out the thing that we want. The list of arguments. So here we kind of go through each argument, and we get the short option, the long option, the extra option, blah, 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 and we check if things are legit. So like if that short option is not a printable character, then we're not going to accept it, so we'll set it to no. And here we kind of check the length of things. So this is just one loop. The first one is kind of checking what the length of the string that we're about to print is going to be, and then it's going to find the max length. Then we're going to go through it all again. And then here, for each argument, we're going to print out some spaces. So everything's going to be separated a little. We're going to get all the options again. We're going to take note of where we are on the line, well, actually in the entire buffer that we've kind of written. And we'll use that later to work out how many things we need to kind of write more. So if we have a short option, we first check, we check it as legit. And if it is legit, then we do that -c. And if we have an extra option for this particular one, we'll kind of print it as a string just straight after. And perhaps this should be something like that, I feel. And then here we go into here, and get rid of that thing. Because here the extra is just that, and so we kind of have it in the similarness. Cool. So if we go back down here, if we have the long option, this is where we check whether we'll print the double dash instead. And if we had a short option, we'll say that you can do the short option or this. And if we have an extra option, we'll put the extra option after space like that. And if we have a description, then we will work out how many spaces to print, and we can use this cool thing. So this is basically saying the next argument is going to be, well, the first argument at this point in the format string, because you can put it anywhere, is going to be an integer, which is going to tell me how many bytes to print, and the next one after that is going to be the string to print. And so we just have a string of a space, and it will print that like that many times. That's just what it does. And we can kind of see that if we kind of go asm -- help. It doesn't compile because I put in some extra things, which we could potentially fix in a second. But that's that. Do that. And the processing is pretty similar, but we kind of make use of the X macros a bit. So we kind of set up this next arg, which does this thing, which I believe is not bound by any like weird edge cases in C, but I believe you can kind of do this. And what it's doing is it's taking a pointer of argv, getting the next arg, and then it's incrementing that pointer as well. So the next time you do it, you'll get the next one. And then it's adding on to it a test. We first test whether argc, well, really all we're doing is decrementing this. And if we just return 0 in both cases, we're adding 0 onto the string pointer that we're returning. So it's kind of not interfering with that, but it does do this argc minus. And I think I tried it with optimizations, but yeah, maybe not. It works. But yeah, so then we have argc, and next arg kind of track whether you can get something or not. And so we go through, we get an argument, then we kind of go through and test whether it is the short code of an option or the long code of an option. And if it is, then we can do some more X macro-y stuff. So here we're basically doing a switch statement. So you see the versatility of these X macros. You can kind of, now it's a switch statement. So we check on the enumeration with a case statement, and then we run whatever code that we had in like a brace, so any declarations don't interfere. And then we kind of exit out of the switch. So that kind of runs the code that you kind of do. And this unreachable could potentially get changed to an actual unreachable. I've got one of them at the moment. I didn't at the time I wrote this. And so that's that. And if you found an option, you'll break out at that point. And I declared the test before the for loop, so that way we can test it afterwards. And if we got to the end and we have a dash, then it kind of means that the user is probably trying to do an option, but we don't know what it is. So we'll say an unknown option. You can run help. So it's kind of nice. Otherwise, if we're at the end, we didn't find any options that matched, we kind of reverse the fact that we got an argument, and then we break out of this whole loop, which was looping over while we still had arguments. So it won't actually consume everything. It'll just consume all the dash options and any extra arguments that I kind of specify in the original macro, and then do that. And that's the end of the arguments. And I think I might do something like that, and I think I might fix things up. Arguments extra. That is, I just need that. Then it'll just do fine. And so that's what it was meant to do. So if we do dash dash help, it does that. If we do dash dash a, it says blah. Interestingly, it says no file name provided. No file name provided. That is in ASM, I believe. Yeah. So if we I thought this thing would have returned an error. In this case, yeah, we should probably be returning one error. So this it returns either like -1, I believe. And so if it returns -1, if it returns -1, it doesn't get checked. Yeah, so -1 means it's fine, go ahead. Kind of reverse of everything else. And if it's 0 or positive, then it is meant to be a return code, and then we kind of reset it. So that's kind of a weird way, but I think that should kind of not say that message now. And you'll see, I just ran that, and it said recompiling this as ASM is newer than the binary, and it kind of just worked that out. And you'll see, like, if I like that, it'll kind of notice that arguments is touched, and if I like do this string builder, it will recompile again. If I touch this, won't. I'll check up on that one. I feel like it should. If I do this one, it'll recompile, even though that's the script that is doing it. If I do this one, it will as well. And this is not part of the source code anymore. So what I might do is find this builder reboot, and I might try and work out why touch source assembler array and do that, and I need to work out why that doesn't recompile. But in doing so, I might walk through this rebuild. So, first off, that's that time. It's dangerous and danger. Could have done bad things. So this rebuild.sh, rebuild.h, it's used in the ASM. So if we find rebuild, we basically include the file. It's got a similar sort of guard to arguments, so you have to kind of define it. And then in main, we have this function rebuild if newer source, and potentially I can macro away some of this stuff, so you don't have to pass in that, and it kind of just works things out. But what this is doing is, in main, file here refers to this asm.c. You can't quite see it, but asm.c, that's what this refers to. And it refers to the way that it was so if I go into just make a quick little thing here, and if I go just printf, do something like this, file do something like that, and if I GCC that, it will complain. We can potentially get rid of that. It will still work. It just magically does it. So if I run this, it will say it's test.c. That's not actually the most useful to me, because I kind of compile it like this. So I get the working directory of where I am, and then I go to the path. And when I run this now, it gets the full path to where it is. And that's kind of important, because in this rebuild if newer source, if we actually find that particular function, because this does a few things. In this rebuild if newer source, so it does a few things. So the asm.c I say is not used, but it is used. So let's update that notion. Cool. So the rebuild of new source, it first reads a link to whatever this is. So straight away, this is kind of only going to work on Linux. But there is this thing here, and it's colored that way because it's a link. And this is a link to ls. And can I do something like read link as well? And yeah, this is now linked to read link. So you see it's kind of just a link to the self, yourself. So it's a link to the running thing. So this way, it's a bit more robust than just taking argv, because if we look at this, so if we give a cn argv, so I might file equals that, and argv equals that, and we can change this to argv. And if we gcc that again and run that, we can see that it's a.out. All right, so what if we look at how we execute things here? I think you can do it, and yeah, we can. So what I can do is, I kind of don't want to do that. I kind of want to maybe run a new bash environment, and then I want to go exec -a, and then like hatch, and then I'll run that program. And you'll see here, argv is now hacked. So you might want to rely on argv, but if I'm going to do some magic with that file as if it is a trusted source, or this is where the file is, and like now I'm going to do a thing, coordinate reset out of my bash, I'm pretty sure, because it exec, it ran, and then it finished. So basically, I'm going to write to this program. So if we find program, we make a command. So cc and a bunch of C flags. Works on my computer. But we pass in the program as the output file for that compilation. So that means it's going to get overwritten. And if we write has or etc/shadow or like whatnot, it might go somewhere else. So for that reason, I read the link. So I have to read the link. It's a kernel call. Oh well. I also get the current working directory of wherever we are. And I'll make a string view of it. We'll get into string views in a bit. But we also get array string t, and this is a type that I've kind of made. It's made in the array.h, which we'll go through. So this is basically a set of files. This function is meant to basically get all the files that main file kind of might include. doesn't quite get array.h, does it now? Because if we do that, doesn't care about array.h, but array.h is included right here. Not directly in asm.h. Yeah, I would have thought. But yeah, so we do that. And then we call this function rebuild any file new. All this is doing is basically going through this list of arrays and calling some things and working out whether they are newer or older than the current program, which is read from that link there. There's probably still ways to hack this, to be honest, because I can kind of make a link. I can call it a dot out and put it maybe somewhere a bit safer. Yeah, clear up that. But yeah, so now if I look at a dot out, it's I've done it the wrong way around. I always do. Temp you wonder if they'll work. And now, if we look at that, it is pointing to something that doesn't exist, and that is because I think it's a circular reference now. Yeah, well, it's not actually because that's pointing to a.out in the current directory of that, whereas that's pointing to a full path. My point is, I can change between this link, this time, and this check or later on. Yeah, actually. Wonder if that follows that link. I'm gonna remove that, and I'm gonna look at this. Yeah, cool. Hacker me is like quite excited. So yeah, this is a binary that I've written to a random place just because I created a link, and so theoretically, you could in between this time and this time do the thing. Perhaps I might make a note of that. Fix me security, security. Could be a time of use race condition between time of check and time of use for program. E.g., program is read link proc. Is self any self exe. Program is that. Between then and now, someone could minus if make a if doing that hacked. I don't know, bin bash been hacked. We'll put it in bin hacked and program. They could run that little command there. So this is pretty much that command there. Then the cc command would follow the link to overwrite. Yeah, it's an interesting one. I wonder if there's a flag to CC to be like, don't follow links. Or I wonder if the correct thing to do is make a temporary file to compile it to that and then move it to the right place, but making sure that you don't follow links on that move as well. Security's hard, folks. I'm in the industry. Makes you think quite a lot. But anyhow, so we were up here before. We have a magic function that checks whether something's newer. If it is newer, then we do some things. So strings views I'll talk a bit more about, but we can talk through as we go. So what this is doing is a string view is basically a structure with a pointer to some data and a size. And the way you can do string views is you can kind of move that pointer around and increment and decrement the size. As long as you don't go outside of the original bounds, that data is valid, and you don't have to kind of reallocate lots of tiny bits of memory. There's improvements in that space for memory allocations and my thing, but we'll get there in a bit. So, what this allows us to do is basically now we have a string view, we can kind of just get the size of this current working view and kind of, we know we can kind of chop that off. And then we can chop off a character there. And we know that we can do that because we never actually pass it to the main file, but we kind of assume that the main, it's kind of interesting. Yeah, let me, I may not start with CWD all the time, but perhaps it does. Yeah, so it's interesting. It only does because the let's get rid of a out. It's only because we're running the root of the source and the binary in the same folder. But if we say we're like in tests or something and then ran asm help. Yeah, so here it kind of said the whole path. I don't know what I'm thinking. Well, I guess, yeah, so, no, this is, yeah, I've even made it so. If you can chop it, so we chop off that working directory, then we also chop off that with this check here, and then we do that. And the whole thing's not working because it's printing out a full path. That's how I know. But if I was back here and then do ASM and then like recompile, yeah, so now it kind of knows that it's relative to me. Room for improvement there. Interesting. Yeah. So yeah, basically, if we found a file, we print out that we found it. Do some bringing of things. And if we found it, we're going to do a thing now. We're going to fork. So forking this command is basically splitting this current process in two, and it's important that we did some freeing there before we did the fork, because otherwise both processes would have that copy of that memory, and the pointers would not line up probably. So I basically closed up everything I've had, and this is one of the first things that's called in main, so it should be a relatively small in terms of memory at the moment. Perhaps like no, no, we still have some because like we just need it. But yeah, so the return of this is either negative to say it's an error, or it's 0, or it's a number. And if it's a number, that means you are the parent, and the number is the process ID of the child. And if you don't have a number, so it's 0, then it means you're the child. And so if you're the child, we can run another command, maybe. So we can run this command. Showed it before. C pointing to a certain file. Here I also kind of print out things. So this is kind of, you can see the recompiling is newer than that. This stuff you can kind of see if I, reloading asm. I think it's that reloading. That comes like down there. What is this doing? Oh no, that's just printing out this. Yeah, so that's just printing out this thing. So prints out the command that it's doing, and it puts in the right stuff there. And I think if we go back here and do that dot dot, it will -o output to the actual place. So I think that's kind of what I'm doing here with the chopping, which is correct. But I think I want to get that fixed me and put it here as well. Right, so that's just all that, and then I kind of talk about this race condition. This is now going to call exe CVP, and there's a big family of exe CB something, or C something. Basically all of these, and it talks about, like, if you have an L, it basically means that you can have one thing. If you have V, it's a different thing. And you can see here, if you have an L, you basically have all your arguments in a parameter called to the thing. Now, if you have a P, then that means this file will be looked up with $path to find the actual file. If you have an E, that means you're also passing in the environment. If you have a V, that means you're just passing a vector. So we can just pass in the same argv. The P, same again. The $path is looked up for that. In the E, you also pass the environment. And what this will do is it will replace the thing. And that's the reason why I wanted to run that exec. So if we go bash and then exec, the reason why I wanted to run the exec in that is that actually kills bash. I wonder if we can trap that, but like that. Oh, that might not have. Yeah. So if you can't, then it will fail. But yeah, I don't know. If I go to bin bash again and then exit out of that, back my brutest one. Pretty sure. Yeah. So now my last command was bash. So if it gets past that, it was an error, and we should always exit, because if we don't, then the child will keep on going and it'll be like, what should I do? And what the parent does in the meantime is it waits for that child. So this will wait until the child exits, or it's signaled by something, or it's like stopped or continued. If you pass in certain options, I pass in nothing, so that means that I'm gonna just wait until I get this particular child back. And if it's already dead, I'll get it back straight away. And so here it can be an error, and like we'll just return, and might be an orphan child somewhere. Otherwise, we kind of exit with the exit code if it was non-zero, and if it's signaled, then we will be exiting with 128 plus the signal code. And if none of those cases was right, that means that this child exited with 0 status, which means this compile was successful. And so that means that we can go through and do some other stuff. And that means we'll print out a pretty print reloading, and then we'll, as the basest like program, we're going to run that exe cvp and basically respawn the exact same program with the exact same arguments. And you can see that it has been doing that when I've been doing that by compiler once, and I go to the right place. But it doesn't when I do array. But any other file, it will kind of do that, and it will reload it with the exact same arguments. So that's kind of handy. Should we maybe talk about these get files, and perhaps in doing so, I'll see whether what the bug is. So this function is called recursively. You pass in a source file path, and you also pass in an array object, which we'll talk about arrays in a bit, but basically it's a storage container that I can put more and more in, and it's just one pointer. And what this is going to do is, first off, it's going to check whether the file that we're wanting to check is already in the array, and if it is, and that's just up here, we go through all the elements in the array, we check whether the length is the same, and then we check whether the actual characters in that are the same. And if that is the case, then that string is in the array, and if we get to the end, then it is not. So if it is, then we just exit. We don't want to do anything more. And perhaps that could be like that. And then we read the source file. So this is going to read the source file into a new string view, which means that we can do a few things. And this will help lead into the string view side of things, because it becomes kind of obvious how it's useful. So we also kind of get a base name string view, which we're going to start off as being the source file path. So it's basically going to be like the actual full path to the source file. So like that with that prefix. And so what I do here, chop right by char. And it's a particular thing. It's going to chop right, and that means it's going to chop from the right-hand side, so the end of the string. And the by means that it's going to, like, basically not chop the end. It's going to go back until it finds that thing that you're buying, and then the characters, it's going to look for the last slash. So it'll go through and find that last slash, and that should basically strip off the file name of the whole thing and leave you with the directory where that file is, which is handy because we're reading that file, and it might have include statements, and it might have relative paths in those includes. And when I say we're reading that file, we're actually going through and reading that file. So we have a tokenizer, which is the source file, which is just a copy of the full source file, but it's a soft copy. We've only allocated memory once for this, and when we do this, we haven't changed it. And the only reason we do this is because I want to keep the original start of it, because this tokenizer is going to shrink from the left. Well, from the top of the file, I guess you could say. And so here what we do is we go line by line through this file. And so here we chop left by one of chars. And so here we have that keyword by, so that means that we're going to basically go until we find one of these characters that we're going to go. And here we just pass in two new line things. So you can have a Windows new line or just normal one, or if you have both, it will kind of condense it down into, it potentially might do 2 lines, but I think not, but I'm not too sure. And this null here is the return of whichever character you're splitting on. So this is kind of like a split, but I just put by. And so if that returned something, we've got a line. And so we can go in the line. And so here we can basically, if we can chop left, and note it doesn't have the by here, chop left string. It is looking exactly for this at the start of the line. And I think you are allowed spaces, so perhaps this could have a trim before, a trim does actually exist. Perhaps I'll get this and just check whether yeah, so spaces do exist. So we can have, we don't use trim anywhere here, but we do in asm. Just get that. And it will likely be exactly the code that I want, except for this is going to be that and that. Boom, done. So that's a similar thing. Instead of chopping and like boom, you're now trimming, which there is a difference. So the trimming means it will do it multiple times. So if I just chopped by charfang on a space, it would just find the first space and then be like, that's your string. The trim will kind of go through each of the spaces and get rid of all of them. And the is space will include stuff like tabs and whatnot. I think even new lines. So there's like is space, white space characters. So it depends what locale you're in. Which, I don't know. Linux is like that. Unix maybe. So space, form feed, new line, page return, horizontal tab, and vertical tab, all in one function. Easy. So yeah, we find this include, and it has a thing. And quick other test. This also doesn't matter, does it? Yeah. So you just need to have like a space, and then we probably want to trim again, and then this can be. I've got another one which is string view chop left char. Let's do that so I can actually see what I'm doing. And so now I just want to chop by the character, which is that. And this returned a thing, I'm pretty sure. Buff string, we need to do that, and we get that. And so chop left char is going to give us a string view. Now I wonder if this is in a loop type thing. So if we don't have an include, I think we just want to continue. If we don't have a quote, we just want to continue. And that way, this whole thing would be able to come down by 1 and not have that. Right, so we check that, we check for the quote character, and now after we've trimmed that quote character. We need a equals after we get that. So basically what we're doing is so in this we have an include file, something like that. And what this has done is it's chopped off all of that, and now it's kind of left with a string that looks like this. Is the whole file, but we're kind of going through and we're getting just the right part of the thing that we want. So now we chop left by char, and what that's going to do is kind of find that character and split it out. And now you've got like this string, which is the rest. So that will be, well, I think line will be that because you first split by line. And then you'll be left with just this text. So if so I wonder if, well, like you could have like some weird cases where we have, I go back to here, you could have something like this, and that's potentially a valid file, but like it wouldn't complain at this point because we don't really check. Yeah, and I'm not sure the function's quite set up that way. But anyhow, if we do that, and if we had a base name, uh, I think it just needs to have that. So if we have a file and we also have a base name, then what we're doing is we're basically adding to a string builder, which is another little thing that basically if can pin things and like the memory will stay allocated each time round in this thing. We'll clear the string builder, but the memory is still there. And so it doesn't actually have to do that many allocations. But what this will do is basically chuck the base name on the start. And I realized like this part can actually kind of be done outside there because everything is going to have that, and it's only going to be different at this point here. So we could almost just roll back to whatever that size is. But anyhow, we do that, and then we get a string view of whatever that string builder has. So we're back in view land. Here, if we have a file, and the file is in there, then we so if we have a file after all of that and we have already seen the file, so like you might include files in multiple files, this file potentially doesn't need to be done, and it's not done in, oh no, this is the right one. Yeah, so we do that, and then we have an include account. So basically, if at this point we still have a file, we include it, and we clear the string builder if we kind of used it. And then we loop through that, and that way we have an include count. So we know how many files that we're going to add to the array, and that kind of means that we can pre-append them, allocate stuff if it needs allocating at all. This is an only growing array, so and then we append the file that we're currently looking at, and then we kind of check where we are at the moment, because we want to go through all of these files at the end and check them. So this is basically doing the same thing as there, so it could potentially be done differently, but you'll see we kind of restart the tokenizer, so it goes back to whatever the original thing was. So it's not actually changing the original file at all, it's just changing the view on it. Quite a handy concept. But yeah, that's just the same thing. do all that. If we have a file, we now this time convert it to a C string, which can allocate memory and most likely will. And you kind of want to, because this could be just backed by the string builder, and it's the same memory. And when we clear it here, it will kind of invalidate this view, which I know about, and this is why you kind of have to do this. And then you append the C string. Yeah. Yeah. Hold just 1 second. I'm back. Yes. So basically, everything gets put into C strings. We do that, and then at the end, we go through and we're now checking it again. And I kind of want to do maybe here and checking files. What am I doing? Checking that and files data, and I believe it is a C string, so we can kind of do that. And if we do asm doing that, oh, that doesn't. We have. Tell me what's wrong. We have not done a space there, and this. This needs to go down here and kind of have that same same kind of logic. Do that. Did we? Yeah, we did. Oh, all right, we'll just do that then. And just do that. Just do that. Cool, and we're all compiled. And so here we can kind of see what it's checking. So yeah, we can. So it's checking that. Well, I kind of also want to say what it found. Found this C string. I have a feeling. Can we? It is what it is. So we have string view builder arguments rebuild and string view string builder arguments rebuild. So it does seem to be getting everything from there. Interesting. I'm recursing at the wrong point. So I don't really want to recurse here because, yeah, it won't ever check another file, which it'll do this check and be like, oh, it's already in here. So I actually want to do that check here, except without that, just with that, and then C something like that. And then append it to the thing, and then do all that stuff, and then now we don't need that start because why did we ever need it? So if we do that, we can do we need all at once? That has made all my tests fail, which isn't great. So it means we have some errors. Tempting to double free. Right, so 207 of this, 207. Just momentary again. Yep, yep, yep. Right, so I want to be back in here, and I want to be this file. What is 207, 207 of this file? We do a free at this point here. This is it's not liking it at this point. So files data is a C string, and it's saying we're double freeing it. So we've already freed this somewhere else. We've already freed it somewhere else at that point. Interesting. When do we free? When do we free anything else? We do I mean, it tells me which one it was freed by that one. So when was it done there? 207. So it was also done in. It's on the same line that it was freed. And it was allocated to a thing. That's kind of funny that it's that. Um, because it doesn't free anything. Um, yeah, it says when I run anything. Can we just? I don't want to change that and change this to all as well. So if we have the ASM now, it still doesn't like that, even though we redone it and it's just the same. That's why we don't actually want to do that array append there because this thing will kind of do it for us. So we actually only want to do that. Yeah, that seems right. And so if we compile that once more, so now if we touch that array, it works. I might kind of add that up with this extra stuff. Or get commit fix rebuilding checking recurse coding. Sure, that's a good enough commit message. Cool. So the string view stuff. Was that everything I actually wanted in the So yeah, we kind of looked at this method, but there was also this rebuild any file newer. All that does is calls stat on a file and stat on each of the files and does a thing to check if it's newer. And if it is, then it returns a pointer to the file that was newer. We also have a way to print a string. So when we're printing arguments, like something like that, it'll kind of quote it for me. It quoted it different, but that's all good. And if we like put in like some fancy code, it will kind of also do that. Which yeah, kind of handy. And yeah, I think that's all from the rebuild. So string view. Haven't talked anything about the assembler, but it does stuff. But string view is potentially the backhorse of it all. So this is what a string view is. A struct, the pointer to some data and a size. Just what I said. And so here we have a way to kind of print the string view in a printf type thing. And what that requires is using that format string that I mentioned before, and it requires a way to kind of manually spill out, automatically spill out the two fields. And you can create a string view from a C string. Perhaps I could, I don't know, I use that a few places, but what it does is it just points it to the same thing and gets the size of the string length. And here we have all the definitions. They're all kind of similar, but all slightly different. Here we have a way to convert it to a C string. We have a way to free it. You should only do that if it's done on this file here. Basically, if you've consumed that. Otherwise, you can clear it, which can be useful, maybe. I have a couple of function type sets. Basically, something that takes an int and returns an int. I would prefer it to be like the char in a bool, but the reason why is if you have is space or something, these are all functions that take an int and return and I'll just have to write wrappers for them all, which potentially I could in this to have like maybe some better type safety, who knows. But yeah, we also have a way to duplicate a string view. So we'll take the string view and kind of create some new memory of whatever that string view is. We have a way to compare it. We have ways to chop left by 1. We also chop left by an arbitrary size. I've got the 1 just so I can get the single character out. Not much error handling with that if you are at the end, so you have to kind of check things. And then we can kind of check chop by various things, so a string view, a string, or a character, or one of many characters, or a character function, or a string view function. So basically a function that takes a string view and returns a size, which is the size that it's that string view is. We also have a chop number, which will actually kind of chop a number, and a secret function that will take a base if you want to get a particular number, but otherwise that will kind of do the right thing. Here we have chop right, so all the same, but from the right. And that is mostly the same. Yeah, that is mostly the same. In fact, they're all the same. But there are some that do not exist on both sides. So we have trim left, so we can trim by a string view or a string or a character, or like blah, 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 blah. And we can also trim right. But trimming by the right, we don't have a string view function. It conceptually doesn't really make sense to have a function that's taking a string view when you're starting at the end, because what size string view are you going to kind of send to it? Whereas chop by left kind of does make sense, because you can just pass in like the entire string view, and that function can be like, yes, but only this many characters. Whereas I suppose like this could do it, but you would have to have a little flag to say that you're coming from the right. Anyhow, I'm getting caught up and stuff. Here we also have chop left by, so that was the by thing. Basically, it's more like a split, and it will kind of consume that character. But I think these also have functions. Well, one has a function to get the delimiter, but I suppose here you know what the delimiter is, here you know what the delimiter is, here you know what the delimiter is. I didn't want that. And yeah, here we also have a way to get whatever it was. And here we have a way to get whatever it was. And we have write, but we don't have the string view. We also have a way to just read an entire file and also write an entire file. When you're writing, you have to use write, not printf, because if you have null bytes, it just won't work. But for strings that don't have null bytes, the helpers up the top kind of work. Otherwise, you can write a file. Actually, no, I could potentially change it to write a file to a file descriptor, and then you could write just standard error or standard out or your log file or whatever it is. Also have a way to hit stump. And I have a little helper. If it's a TTY, then you get color. Otherwise, you don't get color because it looks a bit gross. And you'll see here, I had the same kind of things that kind of. Does that not go? Yeah, this one's special. This also has a string view main, so if you want to just define this function, it basically shows off how you can use it. Counts all the lines, all the tokens in each of the lines. That's not what I wanted. I wanted that. So here's how we do everything. The dupe. Reasonably simple. Doesn't do too much more than what I kind of said. Allocate some stuff, copy some stuff. Compare, also kind of simple. Basically, if the sizes are different, return the difference. If any of the characters are different, return the difference at that point. And strcmp, does that return yeah, so I think like another way you can kind of do that is like returning negative I or I, depending on what it is, but then like it starts at 0, so maybe you have to like offset that by 1, and then you know which character it kind of was off at. So yeah, string view, to string view, you kind of need to allocate space because you need that extra 1 byte, which you might not know whether that kind of exists or not. And clearing just kind of sets it to nothing. Freeing will also do the free. So the chopping, pretty straightforward. We chop F1, we're just kind of doing that, and then we kind of get the last one that we kind of did. We offset things, and you see each of these things are kind of just offset by some size. And here the chop left is actually used quite a lot. You can, well, if I kind of go back and highlight it, you can see it's kind of used in every function. So all of these functions, they just kind of work out a size that needs doing and then do that. The number one's a bit different. It works out whether you have a minus. I think this is not needed anymore. In fact, yeah, I've changed the minus to different things, but I've left it in because in case your tokenizer that you use doesn't use that, then yeah. But yeah, it checks whether you have a prefix and does all of that. And that's if you give it a base. If you don't give it a base, which is default, it will work it out. So you'll see whether it has a prefix of each of the things. And if you got a 0, you got to check whether you got anything after. Otherwise, that kind of dies. And then after you do that, you can just go through and get all the digits and kind of add them all up and multiply by whatever the base is. Do some checking for overflows, I guess. That doesn't really output anything, but I have seen that with, like if I do that one, yeah, it kind of splits up into several tokens, and then a none token, which, yeah, that just exists sometimes. The right ones are fairly similar. They're pretty much copy paste, but changing the direction. The chop by also has a number. The number has to do it kind of backwards. So here we do like whether you overshot, whether you have a prefix, and kind of it saves all of these in string views and kind of works all out and it works. The by, it basically does a loop if the original thing works, and it does a do while, and then on the same thing. And these are all pretty similar. So strcmp, strcmp, and this one has like a equals equals, and then that not equals, but that's all good. And so it's all pretty similar. So the chop by, that one, it will kind of go through each of the thing, and when it does make something, then it will kind of do a split type thing. Otherwise, just returns the entire thing. So basically, you've got end of file, like just chop off, which, yeah, I should probably check some error cases, like if I doesn't really matter because it's only in, it wouldn't compile if it was like that. But yeah, so that's that, and perhaps we can yeah, go to this one, and here we can have a read file. This opens a file, seeks to the end, gets the file size, allocates stuff for it, then reads all of the file, and then it returns that file. Easy. You have to remember to close that. Well, not close, free that. We also have a way to write a file. We have to use open and write, more low level than printf. It's just what it is. And we make sure we write everything. We don't need a flush because we do this osync, which I believe does the flushes for you. We also have a hex dump, which is kind of cool. It has some things to basically set all the colors. So that's kind of a sneaky, like, in function enumeration, which, yeah, it kind of works. And then we have a color for whichever character it is. So here it's all green because it's all visible, but if we do something like, dollar that dB and then like 033, it will kind of see that that's that. If we do like a OXFF, we'll go blue. If we do like just a new line that it does that. Cool. So hexsum just does that. And it does a thing. And we have a way to kind of view that. So we also have a builder, which is a bit smaller. So this also has a capacity, similar thing. We have a clear and a free. And here we have a way to append a character or a number or a string view, or to printf the builder. That's more like append format, maybe. I'm pretty sure that's like append format. Yeah, it is append format. Append format. And I wonder if that has broken anything. I don't even use that function. So where was I? In builder. And that was my thing. So yeah, I'll call it a pen format because I feel like that's what it is. And oh no, that just means that this it magically worked. And yeah, how that will work. So this can be pen format, and we can do that and one more, and so we can do something like that. And then can we get back to where we were? Now we can go back here. Oh, we were somewhere in that part. Cool. Was that still comparing? Oh, but I kind of put it in, didn't I? Builder. Oh, print yeah, yeah. So this thing. All right. Sorry, I'm jumping all over the show. I kind of want this to go away. And I want to like see where this function is and cool. And now that compiles in, it'll likely. Yeah, I'm just running all the tests. Yeah, they will do the parts. Perfect. So, what this does is basically keep track of size and data. So that part's just kind of a view, but it also has a capacity, and the capacity is what grows as you kind of do it. So it's got this ensure kind of function to basically make sure that you have enough capacity that you can add this many more things to your builder. And so it does some magic and does things. In append format, it does a cool thing. We print to a string, which is now, which is documented. I did not know about this. Yeah, it's like only in yeah. So everything kind of went to this, but basically, if you pass null, then it will be the number of things that would be written to that. So you can then use that to ensure that you have enough space, and then write all that data to the allocated space that you know now exists. And the pen char just adds a character. Pen does a bit more stuff. Some stuff. The base 2 has to be done manually, so it does some bit stuff. These ones I can just use the format strings. And append string, we just kind of copy it, easy. Append string view, pretty similar, except view data, and we have a very simple example on how to use it. Now, let me look at what I've kind of gone through. So I've talked through that, I've talked through that, I've talked through that, and that, and that. Let's look at array. So if we looked at array, so this was the thing that was never building because it's kind of included as part of something else. But this has a similar kind of ensure to the string builder because in essence, a string builder is kind of an array of characters. String builder has a few extra functions because like it has some more things, whereas this like yeah, because the string builder knows it's a string, it can do a few more things. Here, like we can just kind of append the thing that we define it as, and the way that we define what an array is we just define it as a structure of a type that we pass in, which has the size and the capacity. And so the type is just the pointer is the data. So here we can kind of define some set types. That's what things are. And so some of them I use in various places. We can also like append a static array or something and many, which really just does that static array after kind of defining one. So that is that. So now the crux of it is all assembly. So I might go to main. So we start off, we do the thing that we've kind of walked through. We check whether we can rebuild anything, and then we process any argument. And if we're all good, we're at this point, and that means we know that this is our source file. And if we have more things, then we kind of complain. Otherwise, now we kind of, if we didn't get an output path, we kind of make one, and that's where we have that allocated thing, which gets checked on free. So now we say what we're reading. We read that many bytes. We kind of print it out, and you can kind of see that when I like do something like that, it will kind of say that read that file and read that many bytes and print them out. And then what it does, it parses a token. Now, so this is a function that I've defined in this file, and it's 1,000 lines long or something. And so this token is basically going to be a part of the source code that has a value to it, like a notion of what type of thing it is. And so here we know it could be a token DB. So you see here, if we don't put anything, it says expecting DB. Cool, we can put in DB. It's interesting. It has no there for empty string, but that's all right. So if we have a DB, it expects a separator. Cool, we'll do that. Now I can't parse an expression. And you'll see here the test is a file, and that's like a file number. So what it's doing is basically getting a DB, and then it's going to parse that DB, and then it's going to trim, and it's going to make sure that it has space after the end. So if you go something like that, like it gets a DB and it gets a number, but then it gets some extra stuff. Like, I don't know what that is. And so like you can't just go straight back into a DB. It will be like can't expect a token at that point there, doesn't know what to do. So that is that. And then once it gets all the values of the DB, because you can also do stuff like something like that, and it will write that to test.bin, and it's written byte 1, 2, and 3 from 1, 2, and 3, and it kind of parsed them all in, and it did some things to kind of work it all out. And then it goes through each of them, and it gets a computed expression, which is kind of cool. This function there does that computing. Perhaps it shouldn't. I'm not too sure. Actually, no, I think it should. And so here we kind of have a few different types of thing. We could have a string. So like if I did hello, to, and then like maybe a new line, or maybe something like that, which I think does the trick. And yeah, so I got hello to, and then I quoted new line. That quote looks a bit better than that gnarly thing. I had to close off that one, and then open a new one and then do that. There's like an escape for singles and singles, but I can't recall what it is. And then here it's written 7 bytes, and if we look at what those 7 bytes are, it's hello, and then 2, and then OA, which is the new line. Cool. So it can do a bunch of things, which you can kind of see by all the tests that were running before. So if it's if it's a string, it kind of appends that entire string view, and if it's not a string, then it converts that computed expression into a literal, which is kind of a weird way to do it, but it usually will not involve that much work. But if the number is outside of a range of so I'm using a type called int ptr int pointer, and so this int pointer is basically something that any valid void star can be converted to and from, and so it's only that range, which is like quite a large range, but like it potentially doesn't fit everything. I use long longs as my literals, but yeah, it kind of works out. And so here we kind of check that it is a scene value. So if we try and like do like 600 there, it's like don't know what that 600 is. It's got to be in that range. And then we at the end of it we append the format AZ. And then at the end we kind of check whether we have anything left over, which means that I haven't kind of parsed it, or there's multiple things. Like I think if I do like, golly, my stomach is doing some things. I think if I do like just db2, something like that, it kind of doesn't know what to do there. But like, what if I do, I'm in that, can I do something like that? And yeah, it's still kind of same thing. So we got a new line in there, DB, but it doesn't know what to do with it. That's fine. So the way I've been doing this, I've got 1,000 lines in this kind of main file, and I've got all those kind of helpers that were doing things. I've been doing it very incrementally. So I started off basically, can I have a file? So it's currently got this, but I started off, can I have a file that can parse a number, multi-digit number, like a hex number? Cool. So now I've got that. Can I check whether it's got a DB at the start? Can I check whether it's got a comma? And if it's got a comma, does it have more stuff after? And like it'll check whether it's got that. And so it's like all very incremental. And it's an approach that I've seen with another C compiler, and I just thought it's a kind of cool idea to like I've got this mine one, which if I can compile this is a valid bootable image that will boot in an x86 system. It'll not do anything useful, but if I can get it to that point, which really is, I've got this part done. I need to add brackets, but brackets are kind of easy. And I need to add dollar and dollar, what they are, and I need to add times, but it's all very possible. But I think for now, this is kind of a good introduction. I kind of talked through it for a bit, kind of right on schedule. So yeah, I might leave that, and I hope people will stick around and look at some more assembly stuff that I'm doing. So I guess my goal is to basically have an assembler that I can assemble my operating system in, and potentially have a compiler that targets that assembler that I can then write my operating system in that compiler in a language that I choose. And the end goal is that I can do all that from within the file system as well. Like I can have an assembler that can produce some outputs and do some cool stuff. But for now, it's a long road ahead. But I'm sure I'll have some fun, and I hope those of you that stick around will also have a bit of fun. For now, though, thanks for watching, and I'll see you next time.